Today's topic is on linear functions. Our outcomes that we'd like to look at today is for us to be able to solve linear equations, solve applied problems that involve linear equations, and then look at some characteristics of linear functions, namely a zero, and finally we'll finish up looking at how we can solve formulas, not linear formulas, but they could be, but for solve formulas for a particular variable. To begin with, we need to look at some definitions of equations versus expressions. One of the problems that many students have is identifying between those two, because when you are asked to, say, solve something, that deals with one of these two but not both of them. Particularly in equations, when you solve an equation, or the word solve would go with equations. An expression isn't something you can solve, it would be something that you could simplify. Another good way of telling the difference between those is equations have an equal sign in them somewhere, and expressions, there's no equal sign. So just when you're going through the course, when they say solve, it's an equation, you need to come up with an answer for it, like 2. But an expression is one where you can't solve it, you can't come up and say my answer's 2. Maybe it simplifies to that, but you need to work through some rules and procedures just to simplify it, but you're not going to get an answer. Your answer is equal to a particular number. Okay? So make sure you're okay with that distinction. Now, when you're solving an equation, it's nice to know what type of an equation that you have, and you need to be able to be good at identifying that. For example, when I look at these 3 equations, one of them is a linear equation, one's a quadratic, and one's a cubic equation. Each of these 3 has a different way of solving them. In the end, we always want to come up with x is equal to something. But in the first one, we have a certain set of rules that'll work. The second one, different set of rules, but in the end, we're still going to get x is equal to something. In this case, we get 2 answers for x. And in the last one, same thing, we get x is equal to something, but in this case we would get, or we have a possibility of 3 answers for that one. So some of the tools that we can use to solve linear equations are ones that you've done in other classes too. Here's some principles that you can use. The addition-subtraction principle. So if I have x minus 4 is equal to 8 and I need to solve that equation, I can use the addition principle, which says that I can add 4 to both sides, and on the left side I'll be left with x, on the right side I'll be left with 12. Okay, so addition-subtraction principle, those are things that are in. The other tool is multiplication-division principle. So if I have something like 2x is equal to 12, I can use the division principle that says if I have a 2 here, if I want to isolate x, I can divide by 2 as long as I divide by 2 on the other side. These cancel, I come up with x is equal to 6. So those are 2 of the principles that you can use to solve linear equations. So here's some examples. This one I would use the addition principle, add 9 to both sides. On this one, looks like a combination one, where I might have to get rid of the 3 and get rid of the 2. In the end, I want x by itself, so I have to get rid of the 3 and the 2. The order that you do that in would be I would first use the subtraction principle and subtract 3 from both sides to get 2x is equal to 12. And then I'd use the division principle. Divide both sides by 2, x comes out to be 6. Now you've done this same kind of thing in lots of other math courses, but I'm wanting that concept of principles to go from one step to another step, just to sort of get ingrained in your mind. Okay, here's one where we will have to use a number of principles. So to solve this one, I would first have to use the distributive principle. So I'd get 2x plus 4. Use the distributive principle here to distribute the negative sign amongst the following bracket. Then I'd collect like terms, so I'd have negative x plus 3 is equal to 7. Then I'd use the subtraction principle to move the 3 to the other side. I'm just going to do that in my head, and I'm going to divide both sides by -1 to give me my final answer of -4. always a good idea to go back and check. And when we get to some other equations, I'll have you go back and check your answer to make sure it's right. But just that idea of using the principles. Use the distributive property, collected like terms, and then I use the subtraction property, and then finally the division property. Okay, so hopefully you're getting that in your mind. Now, one of the questions that we have in this section deals with problem solving. And there's lots and lots of linear equations and linear functions, linear models that are great for problem solving. And here's some steps or some ideas that the book suggests and that lots of people suggest is a good idea for looking at a problem and trying to solve it. So first is to familiarize yourself with the question. Draw pictures, draw some kind of a diagram, write down numbers, just sort of flesh out all of the information the question's given you and information that it's wanting. Then once you familiarize, put these things into variables. So this is where you could say let x is equal to something. Use formulas. Sometimes there's formulas like this, rate is distance over time, or the simple interest formula. Sometimes those formulas are advantageous for us to work on too. Then once I've put them into variables, then carry out the math. Use my principles to solve it. Check to see if your answer makes sense, and check to see if it works out. And then finally state your answer. Here's a good problem here that we can try those questions with you. I'm on a heavy diet right now, and so two of my vices would be bananas and peanut butter. So if I today ate only two things, bananas and peanut butter, that would be a very good day. Anyway, and I say my total calorie intake was 1,200 calories. That's not that many calories for a day, but 1,200 calories. But then they say if I consume twice as many calories in peanut butter as I did in bananas, how many calories of each of those things did I eat? Well, some people could maybe try and figure that out in their heads, and I encourage you to try that. But we can also apply some math to it. First off, familiarize ourselves with it. Okay, peanut butter. Here's some peanut butter, and here I've got a banana. And I'm eating those, and it looks like I eat twice as many calories in peanut butter as I do in, so this is 2 times that I do in bananas. Okay, I think I'm okay. I think I understand the question. Let me start assigning some letters to things. So let's let x equal peanut butter. And let's let y equal the calories that I get from bananas. Now let's look back at the question and see if there's some relationships that we can get. Total caloric intake was 1,200 calories. Oh, so if I add the peanut butter plus the bananas, I'm going to get 1,200 calories. There's an equation I can write down. Unfortunately, it's got 2 variables, so I can't solve it directly, but it is an equation. Then they give me another relationship. They say I consume twice as many calories in peanut butter as I do in bananas. So the number of calories in bananas, the number of calories in peanut butter, so peanut butter, calories in peanut butter, is equal to twice the number of calories that I ate in bananas. That one I have to think about a little bit. Is that right? So if I take the number of calories in peanut butter, then that's going to be twice as many as in bananas. Yeah, that's what this question says. Okay, so now I've got 2 equations here that I can solve, or that I can use to solve my question. First off, I use a substitution property, and we'll talk about this later, where I can say that the number of calories in peanut butter has to be the same. So if x is equal to 2y here, then x up here must also equal 2y. So I'm going to rewrite this first equation as, instead of x, I'm going to write 2y, because x is the same thing as 2y. And then plus y is equal to Now I have an equation with only one variable, and I can solve that. Collect like terms, use the division property, divide both sides by 3, I come up with 400. So the number of calories that I ate that day in bananas would be 400. That's like eating 5 bananas. That's quite a bit of bananas. Anyway, so that's the number of calories that I ate in bananas. So to determine how many calories I ate in peanut butter, I could simply subtract that from 1200. So the number of calories that I ate in peanut butter would be 800. And that would be about 8 spoonfuls of peanut butter. Not sure if I could survive just on peanut butters and bananas. Maybe for one day. Anyway, that's an example of how I can use the problem-solving steps or method to solve a question like this. Okay, let's change gears just for a second. Let's go back to linear functions, and the question that we just dealt with could be a linear function. And one of the terms that you'll come up with is something called a zero of a linear function. And if they ask you for a zero of the linear function, what they're asking you to do is to determine the zero of a function. To do that is you substitute a zero in for y or f of x in an equation. So here is a linear equation. Y is equal to 2x minus 7. If they ask you for what the zero of that linear equation is, what they're wanting you to do is plug a 0 in for y and then solve. So I plugged in a 0 in for y. I have 0 is equal to 2x minus 7. I can use the addition property and add 7 to both sides. So I'll write it up here. 7 is equal to 2x. Use the division property to divide both sides by 2, and I come up with x being equal to 7 halves. So this 7 halves is a 0 of this equation. When we look at a function and on graphs, it would be the point at which the graph crosses the x-axis, or a 0. Okay, that's what that is. Don't confuse zeros of linear functions with what I'm saying down here. It's different than when you're substituting an x in for 0. So when I'm looking for a 0 of a function, I plug a 0 in everywhere I see a y. If they want to know what f of 0 is, then I plug a 0 in for x. So just be careful with that. We'll try some other questions here in a second, I think, that look at that too. Okay, I guess right here in this slide, if they want us to find the 0 of this function, that means plug a 0 in for f of x, and then solve that equation. I can move the 2 to the other side by using the subtraction property, so I get 3x is equal to negative 2, and then use the division property to divide both sides by 3, and I get negative 2/3 is equal to x. This is a 0 of the function. Now for the same function, if I wanted to know what f of 0 was, then I usually write down my formula, 3x plus 2. If I want to know the value of the function when x is equal to 0, that's what this says, then I simply plug in a 0 everywhere I see an x. And so f of 0 with this linear function here would be equal to 2. Okay, finally, last concept that we wanted to talk about in this section talks about manipulating formulas. So if I have a formula like this, simple interest, or a formula like this, the perimeter of a rectangle, typically in other classes you probably have always been solving for I, or always been solving for the perimeter. But we should be able to solve, if we have this equation, for any one of those variables. There's 3 variables there. I should be able to solve for any one of them. So like in this first example, if I wanted to solve for t, I have I equals PRT. And if I want t alone, I can use the division principle. This is being multiplied. If I want to get t by itself, I simply use the division principle to divide both sides by PR. So I would say that t is equal to I over PR. Okay, division principle. Now let's look at this next one, a little bit more intricate here. I have p is equal to 2 lengths plus 2 widths. But they want me to solve for length. So I want to isolate first off this term. Which property do I use? Subtraction. I'm going to subtract 2w from this side, and I'll do the same thing from this side. So on the left I'll have p minus 2w is equal to 2l. I've succeeded in isolating that term. Now I want to get just l. Which property? Division property. Divide both sides by 2. So on the left side I'll be left with L, or the right side I'm left with L, and on the left side I'll be left with P minus 2W divided by L, or divided by 2, sorry. Nice to have an eraser. If I wanted to separate these terms to P over 2 and 2W over 2, I could do that, but typically this is fine to leave your question like that. Here's another question that's a little bit different. It's a similar kind of question where I need to solve for q, but in this case I've got two q's on the same side here. And you think, well, maybe I could take that q to that side and divide by q, but you get into trouble because you can't. You have to have q is equal to something, and over here there's no q's allowed. You can't define a variable in terms of itself. Sort of like you can't define a word by using the same word, I think. Well, I'm not an English guy, but that makes sense. Anyway, so if I wanted to solve for q here, what I could do with these two terms is factor q out. So sort of like using the distributive property or factoring, I can factor q out. I'll be left with 1 minus t inside, and on the other side I have an r. Now I have q sort of isolated. It's q times this. I'll use the division property on both sides to come up with r over 1 minus t is equal to q. That's just another little trick that you can use to solve formulas for a particular variable. So in this little video we have talked about linear equations. We've just reviewed some of the tools that you can use to solve linear equations. We looked at some steps we can use to problem solve, and finally we looked at ways that we could solve an equation for a particular variable. Okay, again, if you have any questions, you can always contact the instructor of your course and they can help you out with any specific questions.